Great. All right, now we're recording. Yeah. Okay. So now we're gonna talk about how the computer can actually make decisions, and we're gonna do this through a new data type. And I've hinted about the Boolean data type before. It's a type that just has the values true and false, and we're gonna see how these Boolean objects, these Boolean types, are being used in comparisons. Okay. So the bottom half of the screen has comparison operators. These in the top half of the screen, they are not comparison operators, even though they look like comparison operators, right? These are assignment statements. And we've learned about assignments, almost from kind of day one, because that's how we store values, right? We store values. And it's unfortunate that they've chosen kind of the equal sign as an assignment. But remember, when you see one equal sign, this is not a test. This is not a test, does y equal 3? This is an assignment where you have a left-hand side, which is a name. The left-hand side will always be a name, and the right-hand side will be some expression, some value. This will always be an expression that evaluates to some value. And we're going to associate the value 3 with the name y, okay? This is not this is not a comparison. The result of this whole expression is the value of that expression from there, okay? Down below, these are comparison expressions, okay? And in particular, the distinction that we need to make the distinction between our single equal, which is assignment, and the double equal down here. The double equals is actually doing a comparison. And so all of these are comparison operators, right? They're going to the result of this expression is either going to be true or false. It's going to be true or false, right? So if x is an integer, x has some value. So to evaluate this expression, it's going to evaluate whatever x is. X has some value. And then it's going to do a test. It's going to test to see if that value, whatever that value is, and remember, x is a name for something we previously stored, so it has a value. So you can evaluate this name x, and it's going to have a value. And if that is bigger than 1, this whole expression will evaluate to true. If it's not, if x actually has the value of 0, this whole thing will evaluate to false. And this whole expression is known as a Boolean expression, and it actually has a type bool. And so now we've learned about a new type, right? Just as a review, what are some of the types that we've encountered before? Well, we certainly know about the table type, right? That's a really big object that we've used in this class. We know about strings. We know about the string type. We know about integers, whole numbers, and we know about floating point numbers, numbers with a decimal. So now we can add a new type. We can add a new type to our list, the Boolean type. And it supports all of the usual suspects, so this is greater than, and names of things that we've stored before can be on either side. Again, it's going to, for this x greater than y, it's going to take whatever the value is stored by the name x, get that value, look at the value stored by the object named y, and then it's going to do that comparison. And we can do less than, greater than, less than. So this, you read this one, the third one here, you read this, we're asking a question. Is y greater than or equal to 3? Okay, and that's either going to result in true or false. Again, here is the x equals y. That is doing the comparison. This will be true if x and y have the same value. Down here, this is, you read the exclamation point as not. This is known, in Python, this is known as a logical not. And the way you want to read this expression in English, is x not equal to 2, right? So if this is, if this one here equals is the test for equality, this is the test for inequality. This will be true for all values of x that are not 2. Okay, this last one is kind of funky. This is the last one is kind of funky. And this is actually perfectly valid syntax in Python. What it's saying is this whole expression will be true, right? We'll evaluate x, and if x is less than 5 and greater than 2, then that expression will be true. Okay? So those are kind of the comparisons. And so now I just kind of, before I go into the demo, I kind of want to revisit this idea of where. So now, right, so we've been making decisions. But we've been doing it with the where method and the R function, right? And what was that doing? It was selecting rows. It was selecting rows based on kind of our R predicate. And so we're kind of familiar with these concepts of right, greater than, less than or equal to. But underneath the hood, the where clause, and this is how the where clause actually works. What gets passed into where is it gets passed in an array. It gets passed in an array, one element for each row in our table. And that array is an array of Booleans. It's an array of values, true or false, true or false, true or false. And what the where clause does, it looks at that array and it returns the rows of T, where the corresponding array has the value of true. And so what that R predicate was doing was it was just generating an array of trues and falses, which then got passed into where, and that is where the selection of the rows was done. And we'll see this in the demo from here. So while I'm setting up the demo, do you have any questions? Okay. All right. We've got 4 minutes. Let's. Okay. So now let's look at the comparisons. Okay. So what do you think about this one? What do you think of this one? So we're asking the question: is 3 greater than 1? So no tricks up my sleeve here. That's true, right? 3 is greater than 1. So what will get returned? The value of that expression, right? The interpreter is going to evaluate that expression, and the value of that expression is going to be true. Okay. Notice capital T, true. That is a valid Boolean type in Python. And so here I'm just asking Python to tell me the type of that expression, right? That's the same expression that we had before, and this will tell me that when I evaluate that too, that will tell me that the type of this is a Boolean type, right? And that's no surprise there. That is just like the integer, the string, and the floating point types that we had from there. And we can actually use that. It is actually, you can think of it as true and false as being literals, like the number 5. The number 5 is an integer. 42.7 is a floating point. Well, the keyword true, just true by itself, is a Boolean, is the literal true, and that type is Boolean. Okay. It is case sensitive. So the true, the literal value of a Boolean true has to be capital T. And the Jupyter notebook cell kind of knows that true is the Boolean literal for true. And so it highlighted it in green for us. And notice when I did the true in lowercase, what's happening, we get an error because we did a lowercase t, Python is case sensitive. It's treating that as a variable. It is saying, oh, this is a name. This is a name of something that hopefully you previously defined. And we didn't assign any value to true. So that's why we get this name error from there. Okay. What about this? Do you think this will run correctly or not? I don't think so. Right? Because this is an assignment. And the right hand of the assignment is some value. That looks good. But the left hand, always, the left-hand side of an assignment has to be a name. And so we're assigning we're assigning some value 3 to the literal number 3. And that just conceptually doesn't make any sense. Okay. So just remember, if we really wanted to do that comparison, we need equals equals. And here's an example where we're using the equals equals. And it turns out that Python is smart enough to know that the integer 3 is actually equal to the floating point value 3. But if you're comparing 2 floating point values together, it's going to go out to a lot of precision. And so that's just something to be aware of. So you may want to either round first if you're doing a comparison between 2 floating point numbers from there. Okay, 10 not equal to. again, that will return true, right? Because 10 is not true. And here we have a couple of values here. And so we can do these with stored things, right? And so what's going on here is we're saying, is X greater than 15? Well, we're going to evaluate X. What is the value of X? Well, we see we save the value 14 to X. So this is doing the same comparison as is 14 greater than 15? And the answer is no. So we will return false. And then by the same token, we're asking the question, is 12 less than 14? And that answer is true. Is 14 less than 20? The answer is true. Now, here's the thing. That's the kind of the in-between operation, right? Is 14 greater than 12, but less than 20? Yes, from there, right? And we can do any expression in here as well. And another thing that we can do is we can combine them. We can combine expressions with and or. So here we're asking two questions that will get evaluated to a single Boolean. Is X greater than 13? And is Y less than pi? And we will do each of those individually, and both of them, because of and, both of them have to be true for the whole expression to be true. Okay, that is a perfect stopping point from there. So any questions about that? No, great. So we'll pick up from here next class. And I will see you all in lab on Friday. If you haven't finished your homework, work on that. And have a great Thursday afternoon, everyone. And be on the lookout for your first individual project coming to you later this evening. All right, bye now. Take care.
Thank you.
Okay. All right. So I think last week on Thursday, we ended about talking, I guess, comparison and booleans, right? And then doing certain comparison in Python, just to use it as a checking method in some sense. So today we're going to resume, in particular, starting from. Yeah, we're going to resume from here, where we're talking about like the comparison operators for certain arguments. And then in particular, I want to show you that for today, to get started, we want to show you that array can also be compared. Okay, so just so you know, like what we're showing on the screen right now is all of them could return 2, right? And then actually checking whether it equals to 2 or not. So you will see soon in our demo coming up that yes, of course, when you're adding like 1 and 0 and 1, and then you can check if it's true with 2, right? This is all Boolean over here. And then true actually in Python is also coded as 1, whereas false is coded as 0. So if you do true plus false plus true, okay, when you check it against 2, I'm also going to return you true. Okay, so that's pretty important for us to remember that true is coded as 1 and then false is coded as 0. Moreover, okay, so remember here they're all just scalar adding up. And we can also do it on top of array. Okay, so the last 2 examples we're showing here, as you can see, is that, well, if we have an array of integers here, 1, 0, 1, then if we do the sum and then we check it against 2, it's also going to give us true. Similarly, if we have an array of true or falses, like just true and false and true in this sequence, when we check that against 2, it's also going to return us true. Okay, so those are useful things to keep in mind when we get started of the new demo for today. Okay, so let me do all of, so I think those ones are done from last week. Okay, and then here we're going to resume from comparisons with arrays. Okay, so again, we're creating arrays first of all, and then trying to do different types of comparisons about them. So the first one that we're going to do, okay, as you can see, is what we call it pets. Okay, and we make array. It's an array of string. Okay, we have cat, dog, rabbit. Okay, so let's do a couple of comparisons that we're talking about. The first one, as you can see, the one that we're going to run is whether pets equal to cat. Okay, so this, as you can see, it's an array of string. Okay, and then in particular, what we're doing here is that we're checking each of the strings in the array to see if it is equivalent to cat. Okay, and that cat, as you can see, is also in a string format, it's in quote. Okay, so when we do that, okay, you will see that it's going to return us an array of true or falses. Okay, because we're checking the Boolean operator over here. True, true, false, false. Okay, so if we just manually check it, I guess that's fine, right? Like cat, the first two are cats, so the first two are true. And then we get a false because it's a dog, another true with a cat, and then dog and rabbit, the last one, they're a false. Okay, so again, this is an example of, yes, the array, just like what we worked on array before, can be array of different data types. Right now we're looking at string, and then you can do comparison with string as well. Okay. All right, so what we're gonna demo now is what I was showing on the slide earlier as well, is that, well, if we know that, well, true is coded as 1 and false is coded as 0, it is the same as, well, if I want to know how many cats are there, right? If I code cat as 1 and then dog or non-cat, I should say, as 0, if we add up those 6 integers, we will be able to get at the number of cats in this particular array. Okay, so this is, well, mathematically we know that it will be true. And then of course, if we do the sum of make array, right? Like if it's true, true, false, false, then just like what we showed on the slide earlier, because true is coded as 0, or true is coded as 1, false is 0. So when we do this, this is going to return us the sum of 3 as well. Okay. But lastly, maybe we want to do it much more efficiently. That will actually directly be doing the sum of pets equal cat. Okay. So what that does, now we know, because this inner part over here, this argument is going to be an array of true and falses, right? And then we're taking the sum of that array of true and falses. So this is actually going to directly tell us how many cats are in this array. Okay, so not surprisingly, if we do it, it's going to return us 3. Okay, so this is a quicker way, I guess, overall, to do this kind of comparison. Or in this case, just checking like how many cats are in here. So really quick here, sum of pets equal dog. There's only 1 dog in it, right? In this pets array. So, oh, sorry, 2 dogs. so then we're gonna have 2 because the 3rd and the 5th. Yes, please, Samantha.
Hi, so my question is about like the make array and the sum of make array. Is it just, does it take the sum of how many instances are true and that's it? Or?
Yeah, that's right. That's right. Yeah, so that's a great point. So here, this demo is that if we do the sum of an array of true and falses, then, well, we know that true is 1, false is 0. Here, this is, yes, within it, as you can see, it's going to be an array of true or falses. Okay, so what this does is actually, I guess, two rounds, right? The first round is checking the inner argument. That's going to return us an array of true and falses. And the sum, just like what we showed it out here, is showing us the sum of the true and falses, where true is 1 and false is 0.
Is it possible to get a count of the falses?
Yeah, I guess, let's see. Yeah, that's a great question. What do you all think? If I want to get the count of falses, what should I do? I guess there are many ways. So maybe feel free to speak up any way that you can think of, and I can do the demo right now here. And the question is for everyone. Samantha, feel free to jump in, of course, but everybody else, like, say, Samantha's question is there a way that we can get the count of falses? And if so, how? All right, maybe instead of waiting here, let me actually, this is a great breakout room question, I guess. So let me do like pretty quickly 1 minute, okay? And then we're gonna come back and then hopefully we're gonna get, I can already think about at least 2 ways to do it, but I'm hoping to see more, okay? Okay, so we'll come back. The question is, how can we get the number of falses? And anyone? You can just directly speak up, unmute yourself and then, or type in the chat and I can do the demo on the screen.
I wasn't sure about getting the falses, but I think I would just switch the assignment from cat to dog.
Mm-hmm. Let's see. So if we do.
Or anything else, really.
Okay. All right. So I guess, let's see. Let me actually move this up because I think we're directly trying to figure out how to replicate, I guess, the sum of falses in this particular pets equal cat. Okay, so the first one, I guess, Lance was saying is doing dog. And I guess we did that just now. So I guess you probably wouldn't directly give us 3 exactly, because it's actually counting the number of dogs. So what's the opposite, I guess? What's the opposite of is cat?
I don't have the answer to that, but I have the answer. I have a different way to find the
Sure,
false.
okay, let me do the other one. Yeah, go ahead, Eli.
If you did like the sum of the array, or the length of the array minus the sum of cats,
Yeah.
I think that would give you the number of non-cats in the array.
Yeah, okay. So if we do this and then minus the sum of pets, go to cat, okay. Yeah, okay. So that's, I think it's one way, maybe not the most direct, but still definitely correct, is that we can count the number of, because again, the array is only true or false, right? So if we know the total number of elements and then minus the number of cats, or like count of cats, then we're gonna get the number of non-cats, okay? So yeah, so that's, like I said, trying to think about the opposite, right, of cats, okay? So if we come back to lens solution up here, because we know what, there is also rabbit, right, in this particular pets array, that we know that, well, if we only do equal dog, I guess this is probably only a subset of how, or like a subset of how many, or the subset of all of the pets that are not cat, okay? Because we can have dog or rabbit. So one way to, I think, resolve this, I think, is that, I think we talked about it, like Jason talked about it on Thursday, that we can do the exclamation mark, and then with equal, that is not equal to. Okay, so that's what I was trying to get, that when we think about equal, we're talking about checking it is cat, okay? But then the opposite of that, the negation of that is not cat, okay? So when we do that, the Boolean operator is gonna be exclamation mark equal, that is not equal to. And I think if we change this back to cat, okay, we'll be able to get 3 as well. Okay, so the logic here is that the inner part is again an array, okay? But instead of array of checking it is a cat, we're checking that it is not a cat. Okay, so pretty much we're gonna get the reversed. I'm sure we're gonna get like false, false, true, false, true, true. Okay, and then when we do the sum over there, that's another way of getting the number of falses, I guess, of the original array. Okay, so I think both definitely work. And again, I acknowledge that when we do the not equal to cat, we're reversing the array itself. Okay, but then if we try to answer Samantha's original question, if we have the original array, I want to know the number of falses, you can either do the sum or the length of this array minus the sum of the array, which is going to be minus the number of truths, you're going to get the number of false. Or if you change, you reverse the array to the reverse version of it. And then if you do the sum, that's going to count the new true, which is the old false. Okay, so all of this are valuable, like I said, and I think this is a toy example that we're trying to show you how to do different kind of comparisons. But in practice, I can see why, like say, Samantha was interested in finding out the false, because sometimes when you're checking certain things, you actually want to know what if not the true counts, but the false counts. Okay, so keep that in mind and think creatively. I think later on we might see similar examples as well. Okay. All right, a couple of more down here. So we just did the number of dogs, right? By changing that equal after that to be dog. And then there's another function or method, I should say, in the NumPy library. Okay, it's called count underscore non-zero. Okay, so that is equivalent. Okay, so let me run that first and then show you what we mean. Yeah, so if you think about, or like just guessing out loud what the term means or what the method is trying to do, is literally, I think, just counting the non-zero or the true occurrences of the array. Okay, so remember my pets equals dog, dog. This is going to be an array of checking whether it's a dog or not, true and falses. Okay, and then again, 0 is, or like false is coded as 0, and then true is coded as 1. So if I'm trying to do count underscore non-zero, I'm doing the same as trying to find out the number of elements, the count of elements that is non-zero. Okay, in our case is non-zero, in this case is true. So that's going to give us, again, just like what we do with the sum. Okay, so this is just another function, a method that is out there that you might find useful. And so keep that in mind, okay? The last one I want to do is, well, let's look at a numerical array. Okay, we're doing X, MB8.A range 20 to 31. Okay, so we know that it's going to be 20, 21, 22, up to 30. Okay, it does not include 31. So if I do this, okay, and then if I do a comparison, okay, I'm interested in knowing how about for each of the elements, whether they're greater or 28 or not. So if I do this comparison, not surprisingly, we're getting an array. Okay, again, array of true and falses. Okay, so only the last two are true. Everything else before that is false. Okay, but just so you know, again, we never touch X itself. Okay, so X is always X itself. Okay, so this is another lesson of, unless I want to do anything about this true or false array, and if that is the case, you want to assign it to your object and access later. Otherwise, you're never going to touch or affect the original array itself. Okay. So Samantha, yeah, please go ahead.
Back to the count non-zero.
Sure.
Is there such thing as count zero or no?
Yeah, great question. I don't know. Let's try to find out. So I always also need to check the, what is it? Let me do it correctly. The library to make sure the documentation is right. Okay, so it doesn't work. Yeah, so I don't think it's there. So if you look at the, so this one is saying that this library NumPy does not have this function itself or the method itself. Okay, that's why it doesn't work. So I think only non-zeros in this case. And again, this is binary in a sense that, like, if it's non-zero, it's going to be 0, right? So we can always get the other one, I guess, in this case, by doing, I guess, 2 ways to do it. Again, whether you do the exclamation mark equal as the negation, or doing the sum, or like the length minus the 0 cases. So you minus the non-zero cases. So you're going to get the zeros in that sense. Okay.
I also have another question.
Sure, yeah, go ahead.
So X is an array, and is it filling it with the numbers from 20 to 31? So like when you say X is greater than 28 and it returns the array, I'm just confused about, like, is it returning everything between like from 20 to 30, or like why are we returning X is greater than 28? Like, then wouldn't it only have like 2 numbers? Or
yeah, no, that's a great point. So, okay, so let me type it out here. So we know that if we assign X to be an array of 20 to 30 in this case, because it doesn't include the last one, right? So if we print it out, we know that it's going to be an array of those integers, 20, 21 up to 30, okay? And then this, okay, this is an example of comparison, okay? This is example of comparison that we know that when we run this, and we saw the output already, but even before doing that, we should recognize that this statement, okay, this comparison statement is trying to check each of the elements of X and compare that to 28. Okay, we're curious about how each of the elements compare to 28. So all of this Boolean operation, as we know, is going to return true or falses. Okay, so that's why, yes, indeed, I guess mathematically, yes, if we're like not thinking about it coding wise, if we're going to do like X greater than 28, if we want to find which ones are the ones, if we know that the array is 20 to 30, then we know that's only going to be the last 2. Okay, but then in the Python world or in the programming world, we know that this particular comparison, the Boolean operator greater, this is going to return us true or falses. Okay, so for anything is smaller or equal to 28, it's going to return us false, and that's why we see all of them. Okay, all of this are 20 to 28. Okay, so when we compare them, it's going to be false. However, for the last 2, 29 and 30, when we compare it against 28, it's going to be true. So that's why in the end, when we do in Python do this kind of Boolean operation and checking comparison here, it's going to give us an array about each of the elements. Okay, not only the ones that we know mathematically going to satisfy this. Okay, so for example, if I want to know how many, right, how many there are that is greater than 28. So based on what we learned earlier, we can do sum. right? And then that will give us 2. Okay. So yeah, so I would say that what we're doing here, all of the Boolean. So if I come back, give me a sec. If I come back to this slide over here, okay. So all of this from last week, okay, those are different comparison expressions. Okay, greater, greater, and greater equal to, equal, not equal to, and then in the particular range. Okay, and then I'm sure there are a few others that you can think of. So all of this, as we know, if it's scalar or scalar, like scalar against scalar, then it's only going to return us true or false. Okay, it's a Boolean. Okay, but then if we're doing array operation like the one that we're doing today here, then just like the example of that 28, okay, compare x with 28, then what's going to return is an array of true or falses. Okay, and then we can do all kinds of arithmetic. Again, remember, if it's an array of numerical values, we can always do arithmetic about them. And then true and falses in particular here, both true and false, they are also considered as numerical in certain degree, because true is coded as 1 and false is coded as 0. And that's how we can do the sum, like what we did earlier. Make sense? Okay.
Yes, thank you.
No worries. Thank you for the questions. All right, yeah, so I would recommend go back to the demo and then try to figure out things and then solve any remaining questions you have. And that's for the first topic. And now we are ready to talk about conditional statements. Okay, the term might sound a little bit vague, okay, but you will see that, well, we already did some kind of conditional statements, and now we're just formally introducing it and trying to cover different types of conditional statements that can work. Okay, so we're gonna work around this what we call like a game. Okay, and then let's try to figure out how to use Python to simulate this game. So the game is that we're gonna roll a die once. Okay, a die of 6-sided die. Let me be more clear. So if it comes up 1 or 2, you're gonna pay me $1. If it comes up 3 or 4, we do nothing. And then if it comes up 4, 5, or 6, I will pay you $1. Okay, so this is what the game is about. Okay, maybe you can already start thinking about how you want to do it and whether and how you can do it in Python. So the idea that we're going to cover today is what we call conditional statements. Okay, the first conditional statement we're covering here is the if statement. Okay, so I'm gonna, here we're showing a workflow. Okay, so if a particular expression, we're gonna execute a certain thing. Okay, elif, so the elif, that stands for else if. Okay, if we have another expression, okay, we're gonna do something else. Okay, and keep doing that, and then until the last option over here. Okay, so before I go doing the demo, I actually want you to brainstorm. I will put you back into the breakout room. Brainstorm a little bit of how this set of if and else if statements might be helpful for you to actually simulate this game. Okay, so notice here we have 3 ifs going on. Okay, whether it is 1 or 2, you do something, right? 3 or 4, you do something, and 5 or 6, you do something. Okay, so keep that in mind. You probably, because once I put you in the breakout room, you will have to access the slides yourself. So it's on our website, okay, if you want to take a look. But the question for you all is based on the if statement, the if else, the general conditional statements that we're showing over here. If you were to write it in Python to simulate this game, how are you going to go about it? Okay. So let's have about 2 minutes and then I'll bring you back. Okay, so welcome back. And yeah, the task here is that if we want to simulate this game, okay, of 3 different if statements, okay, conditionals, that's what we call a conditional statement. Conditioning on certain things comes up or certain things happens, we're going to do an action, okay? And we show you earlier that the general form of conditional statements goes if, else, okay? So depending on how many you're having over here. So the particular demo is T10 conditionals, okay? And let me run the necessary blocks first. Okay, so the simulation, like I said, is rolling a die, okay? And then if it comes up 1 or 2, you pay me $1, 3 or 4, we do nothing, and then 5 or 6, I pay you $1, okay? So just to show you a couple of things, you will see that, well, we are working on, again, in terms of making it as a function, okay? And we call it 1 round, Okay. Of course, we don't need to put in the function, but in the end, we wanted to make it as a function that we can actually determine, like say, if I supply the row number you want, I wanted to know the outcome of it. Okay, that's why I'm wrapping it up as a function. But within the function, you will see it's going to be a bunch of conditional statements that the one talking about. Okay, so work in progress. Let's just do the first one for now. Okay, so you see that the the function format, as we know, we have the name of the function. Okay, we call it one round. Okay, and row is whatever the row that we're going to get out of this die. Okay, the first part we know is that, well, if the row is smaller or equal to 2, that's the first statement up here. Okay, you're going to pay me $1. So in terms of me, I'm going to return, or I'm going to gain $1. Okay, so this is part. Okay, only I understand like it's only work in progress, so it's only the first one. So let's run this and see what we get. Okay. So if we define our function this way, only the first if statement so far, if I supply the row to be 1, we know that the output should be 1, right? Because I will be receiving $1 from you. If we run that, okay, great, it's 1. Okay. However, we know since our function is not finished yet, okay, we only have supplied the options or like the if statements for row small or equal to 2. So if I'm supplying anything greater than 2, well, nothing going to happen because we haven't told the function what to do about it. Okay, so that's why if we run it right now, like say the row is 4, then there's no output or anything. Okay, so let me show you the final correct version of the entire function. Okay, so the function again, we call it one round. Okay, the input is row, and notice here we have 3, okay, different if statements or else if statements. Okay, this is each of them is corresponding to the 3 possible outcomes that we show up in the game itself. Okay, so if we read it carefully, okay, if row is small or equal to 2, okay, we're going to return 1. Okay, that's all good. Notice here, else if row is small or equal to 4, we're going to return 0. Okay, so notice here because we have an else if. Okay, so meaning that whatever we're checking in the second else if statement over here, we're excluding the cases of the first if. Okay, because the natural question, I don't know if you're wondering, is if I'm looking at this function, I will be curious about, well, if I have a row equal to 2, it also falls into this particular if statement, right? Like I said, however, because we have the first if that is looking at row between small or equal to 2, and then the else if, okay, it's else if, so it does not include the first item over here. And that's the reason why also for the third one, if we're checking row small or equal to 6, it does not include the first 2. Okay, so this is one way to do it. Okay, so let me run it. Okay, and then now I'm going to show you, well, if I row a 4, we know that the return should be 0, right? Because it's in the middle if statements. Okay, it's going to be 0. If I roll a 6, I think I will get -1, right? Because according to the game rule, I'm going to give you $1. Okay, so that's why it's -1. And then if I do 15, which is out of the scope, okay, of what we're doing over here, just like before, it's not going to return us anything. Okay, and yeah, so any quick questions or comments about this?
What if like, so for like the winning numbers, what if you couldn't chunk them up in terms of like, 1, 2, 3, 4, and then 5, 6? What if it was like, for me, it's 1 and 5, and for you, it's like 2 and 4 or something?
Yeah, no, that's a great question. So that's what I was saying. Maybe they're already, I mean, even, yeah. So Michael's question is, what if we have some other not easily chalked off version of those statements? And then, yeah, so for example, let's just say if we change the game, okay, let's just say, let me write it down, like down here, so I don't forget and then make mistakes. So this one, let's see, we're doing according to Michael's idea. Let's see. Let's just do this. Like if it's 3 or 1 or 3, okay. Or let me just do this. If it's 1 or 3 or 5, okay, you pay me $1. Okay, if it's an odd number, okay. And then if it's 2 or 4 or 6, okay. Let's do I pay you $1. Okay, so we're only gonna have 2 in this case. Okay. Alrighty, so if we want to rearrange this, okay, or like change this accordingly. So first of all, I guess we probably want to delete the middle one because we only have 2 outcomes over here. Okay, so that will be the first one to do. Okay, and then of course, the first one is returning 1, the other one is returning -1. So that's good. And then here is if it comes up 3 or 1 or 3 or 4, okay, you're gonna pay me $1. So I guess instead of doing this, as we know, we probably will have to do equal 1, right? I think this is right, like or row equal 3, and then or row equal 5. Okay, yeah. And let me finish this one and let's check if this is correct. Okay, so in fact, as we are showing right now, there will be multiple ways you can write those if conditional statements. Okay, and all of those, as you can imagine, is going back to what we just covered about the comparison. Okay, all of them are going to be different versions or different combinations of the comparison. Okay, so let me name it differently so I don't overwrite whatever I have. Okay, so let me define this. Okay, and let's try to see if it's correct. Right? Let's see. So if I do 1, okay, I should get 1, right? Ooh, okay, that's good. I'm actually not entirely sure if I did it right, so that's comforting. And then if it's 2, hopefully it's going to give us 0. Okay. Oh no, -1. I think we're good because it's I pay you $1, so -1 is fine. And let's try one more, maybe like 5, just to make sure. Yeah. So I think this is. I'm sure there are other ways to do it, but just to show you, like say, if it's not easily broken up, like what Michael was asking earlier, you can always make this connotation in a sense, right? Like row equal to 1 or 2, 3, or 5, and then you can go that way. Yeah, Samantha, go ahead.
I was just thinking, could we also use like modulus and like if rolled module or like divided by modulus 2 equals 0, then returning 1?
Yeah, I agree. We should be able to do it. I don't know the code per se for the module. Okay, so what Samantha was suggesting is like this particular rule that we're following right now is that if it's an odd number, you pay me $1, right? If it's an even number, I pay you $1. So instead of like writing all out like this, one way to do is like to do the module. So like say if it's an even number, if we module that with 2, then it's gonna be 0. Okay, if it's an odd number, if you mod with mod base 2, then it's gonna be a 1. I think so. I'm gonna just like, I guess, making myself like a fool here, but let me just try it out. I think it's fine. Let me just do new 2, but I'm not entirely sure about the. Yeah, so I honestly don't know. Like, say it doesn't show up like as a maybe ready function, but the general idea, I don't know the syntax, I guess, let me put it this way. I don't know the syntax, so I cannot say for sure, but the general idea, let's just say if mod, M-O-D, is the module function, okay? If it is indeed the module function that we're talking about, then this kind of code should work, okay? But like I said, I'm not sure if that's the right syntax. Okay, so I will do 0 here, I guess. And then, okay, so let's try that out, okay? Like I said, I'm not too sure if the function itself, the MOD the function is correct. So maybe I'll get something weird. Okay, yeah, so it's not available, but I'm sure it's available somewhere in Python world. I just don't know it. But I think the general approach that Samantha was suggesting is definitely a good one. Okay, Spencer type in the chat, row percentage sign 2. Okay. Thank you. Let me try that out. So do I do, oops, percentage 2. And do I also do, I guess, do 1 here? Or, yeah, because nevertheless, I think we need a comparison statement. Okay, so let me try out what, okay. Yay. Okay, so thank you, Samantha and Spencer. So I think the trick here is that the percentage sign, that's the module operation in Python. And maybe Spencer, if you feel comfortable, you can share how did you find it. But if I were to do it, I would just search online, Googling it, and then try to figure out the correct syntax. Okay, but either one is fine. And we have seen how to do it like in less straightforward way or like more tedious way, I guess. Maybe more straightforward, but tedious because we are just listing out all of them by using OR to connect each of the conditions. Or we can use this module and then go about it, okay? And And oh, okay, yeah. So Samantha also said percentage sign is also modules in Java. Okay, and that's great. I didn't know Java, so I guess I didn't have that knowledge to go ahead about it. But nevertheless, I think you can see that there are multiple ways you can go about this kind of task. And some of them are maybe more straightforward, but maybe a little bit tedious. But then some of them might seem less straightforward, like the module that we're doing over here, but it can be pretty easy to implement, and then maybe less prone to error, honestly. I think this one, if you type something wrong, then something is not working correctly in the way that you want it, okay? All right, so keep that in mind, that the general form of conditional statements, okay, the if conditional statements that we're talking about is having this, okay? So this one is general in a sense that you can have, I don't know how many you want in terms of the number of statements you have. The particular demo that we did is only having 3, okay? The original one, I should say, only have 3. And then the later one that we did has 2. But regardless, the general format follows the same style. And then that can be generalized to many other contexts as you're gonna start doing it for your lab, for homework and the project. All right, thank you for all of the comments and questions.